All right, this is exam 2, Physics 201, Fall 2012. Consider these vectors. Which of them best represents the vector b minus a? So b, we start with b right here, and then minus a would be drawing the vector a in this direction. So it's like that. This is b, this is negative a. So this vector is b minus a, and looks like that is b for number 1. Students had two vectors, magnitude 240, which is the only possible choice. Well, it's have two extremes. You can have 240, that's 240, or you can have 200 and then 40 in this case, and the resultant vector is 160, so it's between 160 and 240, so that is A, 200. Car is accelerating along a flat surface, keyword accelerating. Cannon and the cart fires directly overhead. What does the ball land when it comes back down? That's going to be behind the cart because it's accelerating. Which of these punts has the longest hang time? The time in air is given by the y distance. All right. So A has the biggest y distance, y displacement, biggest time in the air. Which of these statements is true for objects in projectile motion? The maximum height is dependent on the x component of the velocity. That's not true. We just said it was dependent on the y component of the velocity or the displacement. The acceleration in the y direction is constant. Okay, that is true. It's negative 9.8, but just let's look at the others. Velocity of the object at the top of the trajectory is 0. That's not true. The velocity in the y direction is 0, but not the x component. The y component of the velocity doesn't change. That's not true. It changes quite a bit. And the acceleration is 0 in the y direction. That's not true either. So the answer for number 5 is B. Number 6, which of the following is an example of a type of force that acts at a distance? That is a field force. All right, all of these are field forces, so the answer is D. If we know an object is moving at constant velocity, we may assume, okay, if it's constant velocity, that means A equals 0. The object is accelerating. No. Losing mass. No. That might be the case, but we can't assume that right off. There are no forces acting on the object? Not necessarily. The net force is 0. That is certain. That's from Newton's second law, which says that the net force equals mass times acceleration. So if this is 0, this has to be 0 as well. So D is the answer. Which of these ideas was proposed by Aristotle? Remain in motion. Okay, he didn't say that at all. Every action, that's Newton's third law. Natural condition for a moving object is to come to rest. Okay, yeah, he thought that objects had this natural state of rest, and this is Newton's second law for part D. So C. Which of these is the basic SI units of the Newton? This is force. So it's kilogram meter per second squared. That is D. A block of mass M rests on the floor of an elevator that is accelerating downward. All right, so I have this block of mass M. It's accelerating downward. Some of the forces, there's the normal force and the weight going downward. That's equal to MA. So Fn equals Fw plus MA. But if it's accelerating downward, that means that this is a negative number, so the normal force is less than the weight. So that's B for number 10. This figure shows an inclined plane with a block. The block is accelerating up the inclined plane. That means that the acceleration is not 0 in the x direction. All right, so I have Fn plus F equals Fw. Oh, sorry. Fn plus F equals Fw. Okay, that's not true. Fn minus Fw sine 60 equals MAY. Okay, that is true. I think I actually have 2 correct answers on this one. C, all of these are correct. That's not true. Fn equals Fw. That's not true. Fn is equal to the y component of Fw, which is Fw sine of 60. And Fn minus Fw cosine 60 equals 0. Or excuse me, F minus Fw cosine 60 equals 0. Okay, yeah, that's true too. I'm going to have to make a change in this in the class. Let me just draw the vectors. I'm just going to show you the components of Fw FW cosine of 60. See, I think the way that I'm going to change this is that I will make this, instead of sine of 60, I will make this cosine of 60. Cosine of 60. So, yeah, so if I make that cosine of 60, that answer is also wrong. So the answer is supposed to be, oh wait, no, I'm sorry. I will make this sine of 60. All right, and then that makes that answer wrong. So we'll go with B on this as it's written. B is this as it's written, and I'll make a change on the test here. I'll try to update it for the website as well. All right, so that option E should be sine of 60. Option E for number 11. I'll make a note in class for that. All right. For number 12, Dr. Young thinks his students are what? The best ever, just so-so, not so good, or horrible, the worst ever. All right. I gave you a hint, the best ever. Y'all did a great job on the food drive. 800-ish items that we had, and a lot of really great things, lots of hygiene items. And so I was just really, really proud and really pleased. And the other folks in the department and in the university were very excited as well. All right. Position of a particle is given by this function. What is the acceleration for this object? All right, we might just be able to look at this and just see that the acceleration is going to be twice this number. But let's just go ahead and do the velocity and acceleration functions. The velocity is going to be 2.2i plus 4 minus 4tj. Excuse me, that should be outside of the parentheses. And the acceleration then is going to be negative 4j. So for part A, just do these right now. You don't have to do these. You might just be able to look at that function and see that that acceleration is that. But for part A, the acceleration equals negative 4j. All right, what is the magnitude and direction of the initial velocity for this function? All right, well, the initial velocity is given by these numbers right here. So for part B, V naught is equal to 2.2i plus 4j. I know that it's these numbers. I leave this off because the initial velocity is when t equals 0. So I just set t equal to 0 and that 4t term goes away. However, I want to know the magnitude and direction. The magnitude of the initial velocity is equal to 2.2 squared plus 4 squared, square root of that, and that's equal to 4.6. It's in the first quadrant. Theta is equal to the inverse tan of 4 over 2.2, and that's equal to 61 degrees above the x-axis, the positive x. All right, for part C, what is the position and the velocity of this particle at t equal 1 second? All right, the position and velocity. The position at t equal 1 second equals 2.2 times 1. That's from this function up here in the I direction, plus 4 times 1 minus 2 times 1 squared. That's in the j direction. All right, so that's equal to 2.2i plus 0j. All right, and then the velocity at t equal 1 second, this is d. The velocity at t equal 1 second, I'm just plugging in for this function, the velocity function, for t equal 1 second, and it's going to equal 2.2i plus 4 minus 4 times 1 j, which is just 2.2i. And that's in meters per second. And this is in meters up here. So you can see now that because my oh, I'm sorry, I had a mistake up here. This should not be 0j. Instead, it should be 4 minus 2 is 2. So this is going to be plus 2j. Sorry about that. All right. Now for part D, just double check that. All right, now for part D. What is the maximum height of this particle? All right, so this is basic projectile motion problem. I know that my acceleration in the y direction equals -4 meters per second squared. That's from that part A up here. All right, -4 meters per second squared. I also know, and you found this in part C, that the velocity in the y direction goes to 0 at t equal 1 second. That means that t at the top, you don't need to find it because you already know it. It's 1 second. All right. Now, so I also know that v naught in the y direction is equal to, from part B, or excuse me, yeah, part B, v naught in the y direction is up here. It is 4 meters per second. All right, so now I can find my y. Y is equal to v naught y t plus 1/2 ay t squared. And this is, remind you, t top. All right, so that's going to be 4 meters per second times t top, which is 1 second, plus 1/2 of -4 times t top squared. That's 1 second squared. So that's 4 minus 2, which is 2 meters. All right. Now, you could have done that, or you could have just said, well, look, I've already found this value. It is right here. Okay? So either way, you could just answer it in words and say, well, I know that this is the y position at the top of the trajectory because I know that the velocity in the y direction goes to 0, which you find right here, because that velocity in the y direction equals 0. So this must be the topmost trajectory. All right? Now, in part E, you also need to find the maximum horizontal range, x, and that's equal to Vx times t. This t is going to be our total t, and I'm going to use twice the time that we found before, so 2 seconds, because we found the time to get to the top of the trajectory is 1 second, so I'm going to let that equal 2 seconds. So x then is equal to Vx, which I found in part B. Vx is 2.2 times 2 seconds, so the maximum range is 4 meters. So if I were to look at this trajectory, it looks like this. This height is 2 meters, and this distance is 4 meters. All right? That's part E. Okay, here are two vectors, A and B. What is 2b minus A? So if this is B, my 2b is going to be twice that length. Okay, so I'm going to draw 2b and then minus A. If this is A, minus A is in that direction. All right, so that's minus A, and now 2b minus A is going to look like that. 2b minus A. And I'll allow some, sketches there, but I want to see the proportions correct, that you get twice the original length and that you reverse the direction of A. So this is 2B, and this is minus A. Consider this inclined plane. The surface is frictionless. What is the acceleration of the 10 kilogram block? And then for 3 extra points, you can solve the system of equations using Gaussian elimination. All right, so let's just draw all of our vectors that are acting on these objects. I have a vector here. I'll call this FW1 here. FT. Remember, FT is the same for both of these blocks because it's the same block. I have the normal force, Fn. I have FW2. And is that all? Yeah, there's no friction, right? The surface is frictionless, yeah. So now I'll go ahead and draw my coordinate system, recognizing that this angle is 60 degrees. I'm going to go and draw the components of my weight. So this is going to be FW2 cosine of 60, and then this is going to be FW2 sine of 60. And then I can write out my equations. For this M1, I have Ft minus Fw1 equals M1A. And I don't know if A is going up or down right now, though. You can probably look at it, and because of the size of M2, you'll probably think that it's going to go down the inclined plane. And it will. We'll see that in a second. But that doesn't matter right now. All right, I can also do M2, and I have FW2 cosine 60 minus Ft. Let's go ahead and write these actually. Hopefully you're to the point where you don't need to do this, but I have Fn FW2 cosine 60, FW2 sine 60, and then Ft. Alright, so what I've done here are the sum of the forces in the x direction. FW2 cosine 60 minus Ft, and that is equal to M2A. It is accelerating in that axis on the x-axis. Alright, let's do Fn minus Fw2 sine of 60 equals 0. Since there's no friction involved, I don't really need this value. So I'm just going to go with these first two equations. I'm going to go and plug in some numbers. I have Ft minus Fw1. That's going to be 1 kilogram. And I said to use 10 for g, 10 meters per second squared. It makes your numbers a lot easier. Equals to M1. That's 1 kilogram times A. And then for this other one, I have FW2 cosine 60. FW2 is 10 kilograms times 10 meters per second squared times cosine of 60, which is a half, minus Ft equals 10 kilograms times the acceleration. I have two equations with two unknowns. I'm just going to substitute one to the other. I'll solve this one. Ft equals A plus 10. And then I'll substitute that in for Ft. And I get 50 minus A plus 10 equals 10A. And so I get 50 minus A minus 10, 40 equals 11A. A equals 3.6. That's 40 over 11. That's 40 over 11. All right, that's meters per second squared. Notice that it is positive. That means that my block is accelerating in that direction. It's accelerating in that direction. Okay, now I also said you could do this by Gaussian elimination, so I'm going to rewrite these equations in this way. Ft minus A equals 10, and negative Ft plus 10 equals 50. Alright, that's just this equation right here. I just rewrote it a little bit. Now if I write this in matrix form, I have 1, negative 1, 10, negative 1, 10, 50. called an augmented matrix. I want to get it into its identity form. I'm going to get rid of this -1 first just by replacing row 2 with row 2 plus row 1. That's going to be -1, -1 plus 1. Hold on, let's see, I have a mistake here. 1, -1, 10. Oh, yeah, I have a mistake up here. When I wrote the equation, this should be positive ft. If you look back at this initial equation, it's going to be ft plus 10a equals 50. ft plus 10a. So that's going to make this a positive number. All right, so I'll have over here row 2 minus row 1. That's going to be 1 minus 1, 10 minus a -1, and 50 minus 10. All right, so that gets me pretty darn close. I have 1, -1, 10, 0, 11, 40. I'm going to divide row 2 by 11. So divide all these by 11, and I get 1, -1, 10, 0, 1, 40 over 11. So that already tells us our acceleration is 40 over 11, which you already know is true. And now I'm going to get rid of this -1 by replacing row 1 with row 1 plus row 2. So I'm going to replace row 1 with row 1 plus row 2. So that's going to be 1 plus 0, -1 plus 1, and 10 plus 40 over 11. And then I have 0, 1, 40 over 11. So that's 1, 0, 10 plus 40 over 11, that's 13.6. That's going to be my ft, and then 0, 1, 3.6, that's my a. So from this matrix, it tells me that ft equals 13.6 newtons, and a equals 3.6 meters per second squared. If you got this right, it was a +3. Right, this block hangs by a spring inside an elevator. When the elevator is stationary, the spring stretches from the equilibrium position by 0.3 meters. What is the elongation of the spring if the elevator is accelerating downward at 1.1 meters per second squared? So the acceleration is -1.1. There are two forces acting on it, force weight and force of the spring. We know that the force of the spring is equal, the magnitude of that force is k times x. All right, first I need to find, I don't know k, but I know that when the elevator is stationary, that x equals 0.3 meters. And I also know, if I look, this is stationary. I look at the sum of the forces. That's going to be Fs minus Fw equals 0 because it's not accelerating. And so Fs equals Fw. That is Kx equals 10 times 9.8. So K equals 98 over X, which was 0.3. And so my K is 330 newtons per meter. All right, so that gives me K. And now I can look at the accelerating frame. And I get Fs minus Fw equals the mass times the acceleration. And I'm looking for, what am I looking for? X. I'm looking for X. Kx minus mg equals ma. So X equals ma plus mg divided by k. And now I know k. I know all these numbers, in fact, so I'm going to put them in. I have 10 times negative 1.1 plus 10 times 9.8 divided by 330. And that gives me 0.26 meters. That's the answer. 4-kilogram object is moving the x direction at 10 meters per second. 1 second later, it's moving at 20 meters per second, 30 degrees to the x-axis. What is the force in vector notation? Well, I know F equals ma, so I need to figure out what is the acceleration. I know the acceleration is v naught plus vt. Right, so I have these values. V naught is, let's do it over here, v naught is equal to 10I, because it's given right here. And then v is equal to 20 cosine 30 in the I direction, plus 20 sine 30 in the j direction. Let's see, those equal to 17I plus 10j. So I have A is equal to 10I plus excuse me, this is incorrect here. Rewrite this. V equals V naught plus AT. So I'm looking for A, that's V minus V naught over T. So that's 17I plus 10J minus 10I, that's my V naught, over my time, which is 1 second. So it's 7I plus 10J. It is my acceleration. And so if I want to know force, I just multiply that times mass. The mass is 4 times 7I plus 10J. So that is 28I plus 40J. That's in newtons. There are the answers, though this key is incorrect for number 1. It should read B for number 1. That should say B. I gave that answer on the multiple choice.